Yes, so we will take integration here. What is integration? First of all, we should understand. Integration is defined as reverse process of differentiation. When you find out derivative, that is differentiation, and this is called the antiderivative also. Let me write here, like if you have already studied that differential coefficient of say sin x, for example, d dx of sin x is equal to cos x. What do we say? We say derivative of sin x is equal to cos x. What does it mean here? We will say, we have said integration is the reverse process of differentiation. Therefore, we will say integration of cos of x with respect to x is equal to sin x. Here you can see that this is the antiderivative or the reverse process of differentiation. Differential coefficient of sin x is cos x. Therefore, integration of cos x will be equal to sin x. Similarly, we can take few more examples. d dx of say cos x, you have already studied differentiation. So, it will be easier to just recall these things and interpret or simply translate the statement into another form. Differential coefficient of this is equal to this. Therefore, integral of this will be equal to this sin x. This is how we interpret this integration. Of course, we will interpret this in one more way later on when you study definite integral, but here we will see that integration is the reverse process of differentiation. So, let us take a few more examples here. We are saying derivative of cos x or differential coefficient of cos x was minus sin x. That will mean here that it will imply that integral of this minus sin x with respect to x, we write here dx, which means with respect to x. Like here we say we are differentiating this function with respect to x. Here we will mean we are integrating this function with respect to x. So, we write dx to indicate that. So, integral of this minus sin x will be equal to cos x. Similarly, let us take few more. d dx of that tan x, we have already done, is equal to sec square x. Differential coefficient of tan x is sec square x, or the derivative of sin x is equal to that tan x is equal to sec square x. This will imply here that integral of this sec square x with respect to x will be equal to this tan x. You have seen few more. Differential coefficient of that cot x with respect to x was minus cos sec square x. This will imply here, just we are translating it, writing in the reverse form. We will say integral of this minus cos sec square x dx, that is with respect to x, will be equal to this cot x. Differential coefficient of sec x, you have seen. Differential coefficient of sec x or derivative of sec x is equal to sec x into tan x, product of these two. Here we will mean, we can translate, this will imply that integral of this expression, which is sec x into tan x, product of this, will be with respect to x will be equal to sec x, like this here. You can say this is sec x. Okay. One more, d dx of that cosec x was minus cosec x dot cot x. Differential coefficient or derivative of cosec x is equal to minus cosec x cot x. We have seen that. Here we will say, we will translate this and state that integral of this expression minus cosec x dot cot x will be with respect to x will be equal to what? It will be equal to cosec x. Okay, this is equal to cosec x. And now little more, you can say amendment in the form of writing them. Here we are saying integral of minus cosec square x is equal to cot x. The same thing can be written as integral of cosec square x will be equal to, this negative sign goes the other side, and now you can write this will be equal to minus cot x. The same thing can be restated in this form. Okay. Similarly, differential coefficient of cosec x was minus cosec x cot x. So, we said integral of minus cosec x cot x is equal to cosec x, and similarly we can say this sign removed from here, and you can mention this will be equal to minus cosec x. So, integral, instead of remembering or writing the formula for integral of a negative quantity into is equal to something, we prefer writing integral of cosec x into cot x with respect to x is equal to cosec x. Similarly, this also can be changed. Instead of writing it as integral of sin x dx is equal to cos x, we should write, we will prefer writing it as integral of sin x is equal to minus cosec x. So, these are few examples how you can relate it, that if the derivative of one expression is equal to the other, then integration of the second will be equal to the first one, like that. Here there is one more thing which is very important. When you write integration, you are relating it with the derivative, and let me erase it and give you some examples. If you said d dx of sin x is equal to cos x, we have converted and restated as the integration of cos x is equal to sin x. See, if you consider d dx of not only sin x, but we can say sin x plus 5. Simply we have added a constant 5. So, integration, so this will be equal to, this is cos x, and of course, that in differentiation of 5, which is a constant, will become 0 only. And therefore, you can say that in cos x when integrated may give you sin x plus 5. Similarly, if you say d dx of that sin x is equal to say 1 upon 3 is equal to what? So, derivative of the sin x plus 1 upon 3 is equal to cos x once again, and when you differentiate 1 upon 3, which is a constant, will give you only 0. So, we are not writing that. So, what does it mean? That when you go to integrate, you can say integral of cos x may be sin x, or integration of cos x may be sin x plus 5, or integration of cos x may be sin x plus 1 upon 3, and even you can say d dx of that sin x plus any constant will be equal to cos x only. And therefore, integral of cos x may be written as only sin x, or sin x plus 5, or sin x plus 1 upon 3, or sin x plus any constant here, because when we differentiate a constant, that becomes 0. So, you do not know what constant must have been added here or written here with a positive sign or maybe even negative sign, because c may be positive or negative. On differentiation it will become 0, and therefore, on the right side we are getting only cos x every time, whether it was sin x or sin x plus 5 or sin x plus 1 upon 3 or sin x plus any other constant c, which may be positive or negative even, right. So, therefore, you will say this. So, that is the reason that whenever we integrate any expression, we always write that integral of cos x may be sin x or sin x plus 5 or sin x plus 1 upon 3 sin x plus any constant. So, we say whenever we will be writing this formula for integration, we will be writing integral of cos x may be sin x plus any other constant. Similarly, integral of this sin x will be equal to minus cos x plus any other constant, because we do not know whatever constant it was when it was differentiated, that has become 0. Similarly, integral of sec square is equal to tan x plus c. Integral of cos x square is minus cot x plus c. Integral of sec x tan x is sec x plus c, and similarly integral of cosec x cot x with respect to x is minus cosec x plus c. We say here c is an arbitrary constant. C may be any arbitrary constant, which if it was present here on differentiation, it has become 0. So, therefore, we have learnt now that whenever we will integrate any expression, we will write the expression of the result and always put a constant which is an arbitrary constant. So, we will say plus c every time. So, in the answer sheet you may not get that written plus c, but you have to write it, because the correct answer will be that these results plus c, which is any arbitrary constant. Okay? Let me proceed a little more further. If you had differential coefficient of x to power n, it was n x to power n minus 1. Let us translate this also. Differential coefficient of x to power n, where x is the variable with respect to which we are differentiating here, n is any constant. It was equal to n x to power n minus 1. So, if you go to translate this in the form like n then x to power n minus 1 to be integrated with respect to x, that will become equal to x to power n. Okay? That will become x to power n. But you know, instead of writing or learning a formula in this form where something has been multiplied also, we will prefer writing it this way, you know, x to power n minus 1 with respect to x to be integrated with respect to x, and this constant which is written here can be taken out and even can be transferred to the other side, and it will become like x to power n divided by this n, right? And of course, as we said, we will be putting plus constant. We have done it. Integral of x to power n minus 1 dx is equal to x to power n divided by n plus c. Still, this formula is not in a very suitable form. You know why? Integral of n minus 1 we will have to consider. So, we simply relate when it is n minus 1, n is any constant, x to power n minus 1, then the result has come x to power n. This n is 1 more than this, and whatever is this value we are dividing by this. That is, whatever is the new exponent after an integration, we are dividing it by the same thing. We will prefer writing it as integral of, if it was n, when it was n minus 1, it has gone 1 more than that, that is n, and divide by the new power. So, we will write here x to power 1 more than that, n plus 1, divide by the new power. So, this will become a standard formula, integral of x to power n, where n is a constant, is equal to x to power n plus 1 upon n plus 1 plus c. Of course, we will have to restrict something which is very common. We all know that whenever we divide any expression by an unknown, we should restrict that the denominator should not be 0. We will have to restrict here that n plus 1 cannot be 0, because in that case something upon 0 will not be defined, or else you can write n should not be equal to, you take it to the other side, minus 1. And you can check it here. What happens if that n goes minus 1? So, we will say, if it is, as an example, if you say integral of x to power minus 1, which is actually, either you write it this way or you can say integral of 1 upon x dx. So, rather it will be better that if you have to start that problem, say integral of that x, this 1 upon x with respect to x, we will be writing it as x to power minus 1. You have taken this exponent to the numerator, this expression to the numerator, and if you apply this formula, which has a certain restriction of, we will see once again, it will become n plus 1 minus 1 plus 1 and divide by the new power, which is minus 1 plus 1 plus c. And what do you get here? You are getting x to power 0 divided by 0 plus c. What is the meaning? It has no meaning actually, because you know, division by 0 is inadmissible. It is not allowed to divide any expression by 0. So, that is the reason it has been mentioned there that n should not be minus 1, right. Just one more. If you have to integrate, say only 5, for example, you have to integrate only 5 with respect to x. This can be considered, say 5 into x to power 0. You know, x to power 0 is 1. So, 5 into 1 will be 5, and to be integrated with respect to x. For differentiation as well as integration, these constants can be taken outside 5, and this will become, now using that formula, x to power 1 more than this exponent, n plus 1 means 0 plus 1, 0 plus 1 divided by the new power, which is 1. So, it will become 5 times x to power 1 divided by 1, or you get only this much. So, if it is integral of 5, you are getting 5x. If it was say integral of 3 dx, it will become 3x plus c. plus c, of course you should put here. Integral of say minus 2 with respect to x, you will say same coefficient minus 2 and x only. So you can recall differential coefficient of 3x was only 3, integral of 3 will be equal to 3x. Differential coefficient of minus 2x would be minus 2, integral of minus 2 will be equal to minus 2x. So if you have got a constant only like 5 or 3 or something, its integral will be the same coefficient times x, and that will be the answer. Okay, that's it.